Good evening and welcome to the Q&A session 15 from the playlist of JEE Advanced Physics. The topic is the electrical field, charge density and electric potential. So based on this topic, I have selected one question for this session which was asked in the JEE 1999 examination. So the question here is, an elliptical cavity is carved out in a perfect conductor as shown in this figure. So this was the figure which was provided in the question, and a positive charge Q is placed at the center of this cavity as shown in this figure, and here A and B are the 2 points which are lying on the surface of this elliptical cavity. So we have to find the correct options from these four. So the first option is that the electrical field near A is equal to the electrical field near B. So we know that the intensity of electric field is proportional to 1 upon r square, where r is the distance of that point from the charge. So here, since this is an ellipse, so I'm just drawing one figure here like this. I'm just drawing the major axis and the minor axis of this ellipse. So the let us say this is the point C here and this is the point D here. So this DB is the major axis and AC is the minor axis of this elliptical cavity, and here OB is greater than OA, and because of this the intensity of the electric field near A, let us say this is EA, this will be greater than the electrical field intensity near B, because the value of R in the case of the value of R when we are calculating the intensity of electrical field near A is less in comparison to the value of R when we are calculating the electrical field intensity at the point B from this charge Q which is placed at the center of this elliptical cavity. So this option is wrong. Here in this case the electrical field near A will be greater than the electrical field near B. Now let's come to the second option, that is the charge density at A is equal to the charge density at B. Now here, since OA is not equal to OB, here OB is greater than OA, so here the charge density at A will not be equal to the charge density at B. Now the third point is the electric flux through the cavity is equal to Q upon epsilon naught. So we know that by the Gauss law, the flux through this electrical cavity will be given by the formula, that is Q upon epsilon naught, where Q is the total charge enclosed by this elliptical cavity, and so here in this case the total charge enclosed by the elliptical cavity is Q. So the flux which will be passing to the cavity will be equal to Q upon epsilon naught. So this is the correct, this third option is right. The fourth option is the potential at A is equal to potential at B. Now we know that in the case of a conductor, the potential inside the conductor and on the surface of the conductor are constant. So the potential at A will be equal to the potential at B. So this option, that is the option number D, is also correct. So in this question there are two options which are correct, that is C and D. C and D are the correct options. So this question was simply based on the basic understanding of the electrical field, the charge density and the electric potential. So in the next session I will be coming up with a different type of a question which was asked in the advanced paper, so till then have a nice day. Bye.